The model is trained using MRI scans of both normal brains and ones with tumors. After training, the model is then able to classify scans based on what kind of tumor they contained. In our federated learning model, multiple machine learning models are trained independently on different datasets, and then they are aggregated on a remote server to create a new single model. This new model will then be able to classify tumors based on their type, just like the individual machine learning models were able to do. I have a quick code demo of our federated learning system here. So we have a server, which will run our federated learning system on for aggregation. And then we have 4 different clients on the left here. And these clients would represent different hospitals or other facilities that we send our models to for training machine learning models on their own data sets. So these would be 4 different hospitals with 4 different data sets, and they will train individually and then send their information over to the aggregation server here, and that will create one final model. So I'll run the server here quickly. And now we will run one of our clients. So this would represent a hospital running our client on their end on their own data. And we should see the server receive an update from that client in a second here. Yep, there it is. Received the initial parameters. And now we will start running our other clients here. Okay, so these are all running. And in a second, we should see the federation learning beginning. So here it's training on 2 of the clients. So they would be training on their own data sets. And this will take a little while. They train individually, and then they update it to the federated learning model. So the federated learning model currently has an accuracy of 36.29%. And now it's running 3 of them at a time. And we see an increase in accuracy here as more data has been received and more models have been aggregated together. And this will keep running on different combinations of the clients or just on all clients in general to update the aggregation server. And I'm going to cut the video here and show you what it looks like once all of them have finished running their models. All right, our models have finished running here. So you can see that they have all completed, and they have now sent their models to the aggregation server, which has also completed the aggregation. In the end, we have a aggregation accuracy of 0.5812%. It seems kind of low, and we think this may be because we have different orientations for the MRI images that we fed into it. Some of them are top-down views, some of them are lateral slices. So we feel like that may have an effect on it. And we also used a fairly small data size for each of our clients because we had to split our data set into 4 to have 4 separate data sets here. So we believe with a larger and more consistent data set that this accuracy could be increased significantly.